So this recording was made on a Windows machine where there's a new Start menu shortcut that launches what looks like a Command Console session, which is going to be hosting the back-end process responsible for serving up the designer in your web browser, in our example on localhost port 7500. And we're just going to explore the various icons we have down the left-hand side of the web UI here. On the designer page, if you've created any flows previously, this is where they'll be shown. So we have a couple of pre-existing flows in this example. We're going to be creating a new one from scratch in just a moment. On the catalog page, we have a very large number of options for connecting to third-party applications. It's here that you typically fill out the credentials required for connecting to one of those third-party apps, and we've already done that for the sake of Salesforce and IBM Cloudant that we'll be using for our example. On the logs page, we can see the various messages that relate to what the flows are actually doing once they've been created. But we're going to step through the whole process and actually create a new flow from scratch, which interacts with a Cloudant database. So in this other tab that we have open in the browser here, we can inspect what that database structure looks like. There are multiple different JSON documents, each of which describes a different kind of a vegetable. A vegetable has an ID, which is its name, it has a color, and then it has a rating. And we're going to run a query against that backend Cloudant database using a flow for API that we're going to create within Designer. And the basis for creating any kind of flow for an API is to first of all create a model. And the model has a set of properties that represent the artifacts that we're going to be calling, the various resources we're going to be interacting with. In this example, we're just going to deal with a few very simple string fields. So we have the name, which is the ID of the vegetable. Then we have the color field and a rating field. And for each one of those resources that we've created, we can then provide an operation. In this particular case, we're going to implement the retrieve operation, and we're going to retrieve by ID. And that retrieve operation is going to be executed against Cloudant. So you can see here we've chosen an existing Cloudant connection. We're going to expand the option of all of the interactions with documents, and we're picking the retrieve document option. We're going to retrieve a single item, a single row, single document in this example, and we're going to use a where clause to filter the particular document that we're interested in. So we're going to provide the name of the vegetable from the input message coming into the REST API, and we're going to use that as the document ID that we go off and retrieve from Cloudant. So we're now going to edit the flow and add a further toolbox node after the interaction with Cloudant. In this particular example, we're retrieving a JSON document from Cloudant, which could take many different forms. So what we're going to do here is use the JSON parser to parse the response that we've got back from the IBM Cloudant node. And the first one of these items is to take the document data, which could, of course, take various different forms. In our particular case, because we were looking at the database a moment ago, we can paste in here an example of the kind of JSON that we would expect to receive and use that to generate a schema. So you're not always lucky enough to have an existing JSON schema to describe your data, and the tool handily helps us with creating one from scratch. The last job we have in the flow is a mapping job, and we're using the JSONata Mapping experience that we have in front of us here to map what the fields should look like in the response message sent back to the original requester of this API. So we're passing back the color and the rating that have now been parsed using that JSON parser node that we were just looking at a moment ago. So we're mapping in there the tasty index field that's come in from the Cloudant database. And just before we test the flow, we're just going to rename the flow in the top left corner here. We can type in a new name. So this particular one we're going to label as Vegetables API 3, and then click the big button saying Test the API. And this enables us to put some test data through that flow that we've just created and see what it does. So switching to the Test tab, you can see in this case we've only got one operation. It's a get operation. And then we can use the Try It tab. If we zoom in slightly, we can then scroll down to find the fields that we have to provide as part of our input. And in this particular case, we've just got one field that we need to fill out, which is the name of the vegetable. It's the identifier that we were looking at in the database a moment ago. And when we send that data in, we get a successful response back, in this case showing us that tomatoes are both red and ketchupy. We can do one more example, and we can try to retrieve a cabbage, and the cabbage example here is somewhat cabbagey. And with that, we have our example. So here we are in the IBM App Connect Enterprise Toolkit, where we'll be focusing on patterns in a moment. But from the welcome page here, we've also got a link to tutorials. So we're going to have a quick first look at tutorials and then switch to patterns. And you can see here the tutorials are used for some very simple scenarios just to get up and running with the toolkit for the first time. They've got a handy little search box. Every tutorial has been tagged with some keywords. And you can see here we can choose one of those tags, such as JSON, and then navigate to all of the JSON-related tutorials. But we're going to go to patterns, and patterns are quite similar at first glance in the sense that you can search them using tags, and you can also categorize them. In this example, we've got 5 different categories. We're actually using 2 of those categories at General Availability Data version 13, and the other 3 are provided for future expansion. And the one that we're looking at an example of here is a format transformation pattern, all to do with converting JSON documents into XML documents. And by clicking the Start button on a pattern, we then go off to public GitHub to our Open Technologies for Integration site, from where we source the installation of the pattern into the local toolkit. So we're just selecting a couple of boxes there to say, yes, we trust this content. And then the pattern is installed inside the toolkit, and in the Patterns Explorer view, you get a view of all of the different patterns that are available, which ones have been installed, and you'll see the one that we've just added at the very top of the dialog in the top left corner called JSON to XML. We have a Create New Instance button that we've just selected, and we're giving a name to an instance of the pattern that we're going to be creating. And this pattern instance records the answers to some very straightforward questions that we have about the kind of artifacts and resources that we're going to generate. You can see that some of these involve typing answers to string fields, to string questions. Other cases, it involves selecting a button. In this particular case, on step 4, we can choose the kind of transformation node that we'd like to use within the pattern. We're going to choose Compute Node in this example, just to move away from the default and show how we can then generate a pattern instance that has a compute node inside of it. Having clicked the Generate button, we're given an HTML page here that summarizes the solution that's just been created and gives some step-by-step instructions for how to then test that pattern instance out. So collapsing the projects there and expanding the other one, this is the actual application that's been generated. It's named after the instance name that we typed a moment ago. And within the application, we have a message flow that is involving JSON to XML transformation. We can see a compute node has been generated, just like we asked for, and the purpose of the code inside this node is not just to switch the JSON message to XML, which is very straightforward, but then also to apply a namespace to each of the fields in the output. Before we can then see that in action, we need to have a test server that we're going to use where we can deploy the flow and try it out. So we're just creating a local test integration server within the toolkit here, and that takes a few seconds, and we get a success message to show that it's been created. And then we're going to use the recording button, the flow exerciser button at the top of the page there, in order to deploy the message flow that we've just generated using the pattern, and we're told that it's ready to record. Now, alongside this pattern, we've also got some experimental data that's been provided. So we have a JSON message all ready to go as input, and this particular message represents a number of different people. So we have Joe Bloggs, we have John Doe, and we have a representative from Holland and another from Germany, more on the data structure in due course. And when we look at the dialog here, we can see what that JSON looked like that was sent into the message. Scrolling to the bottom, we see the various different stanzas relating to the different characters I was just describing. And then when we turn to the response message, we can then see the same kind of data, but represented in XML format. So here we've done the transformation successfully, and each field in the message has now been appended to with a namespace prefix. So this shows that the code that's been provided to loop over that structure and add namespaces has also been successful. We can see there Otto Normalverbraucher from Germany has been added in. And then when we click on the individual nodes in the flow and the wires between them, we can then see that data structure being altered as well. So that was the JSON structure, and we click on the terminal here, we can then also see the equivalent XML structure with the namespaces shown in the right column. And that concludes the demonstration. So in the interest of time with this demonstration, we start from a flow that we've already constructed to contain a Salesforce request node, and we're looking at that node's properties. And you can see at the base of the dialog, we have a set of request properties, including some map inputs. And those map inputs can be furnished with the addition of a JSON schema. In this example, we've defined a very simple JSON schema to take the surname of a contact that we're going to use when we make an invocation against Salesforce. We're also going to create a test server that we'll be using later in the demonstration to actually try out the flow. And when we create a test server, you'll notice an option at the base of the dialog here to create what we call an external directory vault, which requires us to have a vault key. This does symmetric encryption and is a very safe way of storing away credentials that are used when interacting with third-party systems. You can see the projects that have been generated for this local integration server and its associated vault. The success message shows that the server has been created, and if we look in the view in the bottom left corner, we can see that the external directory vault is there too. More on that later in the demonstration when we can interact with the credentials that have been put into that vault. But before we do so, we're going to launch connector discovery from the Salesforce node here and define the name of a policy project. A policy project will hold the policy definitions that tell the product how to interact with Salesforce, how to locate it, what its parameters are. When we launch the connector discovery process, we're going to connect live into the Salesforce system in order to query back information about how to interact with contacts within Salesforce. The first thing we need to do, though, is to teach the tool how to communicate with Salesforce. We need to say what we'd like to gather back. So we're going to do a retrieval of contacts, and then when we click the Connect button here, we would fill out the various parameters needed to successfully connect, including the login URL, the username and password, and so forth. With the magic of a video, I can speed over that step here, and you can see that I've filled out the various fields. So we've got 5 fields that have all been filled out there. And then when we click the Connect button, we can make a live connection to that Salesforce system. And if that's successful, the Save button will become active, and we can save away that connection information. The next stage of discovery requires us to dictate the number of items we want to retrieve from Salesforce. In this case, we're only taking one item, and we're using this where clause to dictate which item we'd like to retrieve. In our case, we're searching for a contact whose last name matches a value of surname that has been passed into the HTTP input node at the beginning of our flow. By clicking the Save button, we've now saved that discovery session information, and we can return back to the main toolkit. And here we can see, once we resave the message flow, that the red cross against the Salesforce node has now gone away, and we can start the job of configuring the next node in the flow. This is an example of a JSONata map node, and that can also be furnished with example schemas. Because we have a schema from the Salesforce interaction, we can add that into the table of the map inputs here, and that can then be used when we do the configuration of the mapping itself. Storing away that information enables us to then click the Configure button that will launch into the mapping experience. And when that comes up, we can start to describe the way that the properties from the input schema should be mapped to the output schema. In this particular case, we're going to define what the output data structure looks like. We're not interested in much of the detail that comes back from Salesforce, but we're going to pick out a few key fields. So we have here the first name of our contact, the last name of our contact, and a description. And by clicking on the button, we can then edit those properties to receive mappings from our input data. In this particular case, we're going to be taking those map inputs from the data structure that was returned to us from Salesforce. So you can see the large number of fields in these drop-downs being reported as a result of us having done discovery against Salesforce. So we can just scroll through the list here, select the first name, select the last name, and the last one is quite a way down the description. So we're going to use the scroll bar here and go down to where we find a description of the contact. In this very rudimentary example, we're going to be looking at the description of some footballers who happen to be inside my Salesforce system as my contacts. When I click the Save button, that JSONata mapping has now been saved away. We can dismiss the available dialogues, and then when we return to the message flow, if we hit the Save button, then the remaining red crosses go away on that flow, and we're in a position where we can begin to test out the flow. You'll notice here that the policy project has a policy inside of it, And when we refresh the view of the external directory vault in the bottom left corner, we now have the credentials that we filled in all about Salesforce when we were going through that discovery process. You can actually create credentials directly. It's not just through the discovery process. You can come in here and create your own bespoke credentials for interacting with third-party systems. All of the credential types are pre-coded, and the authorization methods for each of those endpoints is also known about in advance. We can deploy the policy project down into the integration server and then click the record button, and this will deploy the message flow itself. When we agree to the dialogues, we'll be in a position of having deployed the flow in a ready-to-record state, and then we can inject some data that drives the message flow itself. We're going to add a new message here and type in a very simple query string, which will involve the value of a surname. We're choosing Kane, and when we send that in, we will find out if there are any contacts in my Salesforce database, and there are in this example, Harry Kane, who, according to his description, is a legend. You'll never guess which football team I'm a fan of. And with that, we can then see the passage of the data through the flow. We can click on an individual wire between the message flow nodes. In this example, we can see lots of information about Harry Kane, about his assistant, the Mr. Son Heung-min, and all the various dates in which the records have been modified. At the very end of the flow, we can then see the final data structure where we've just got the three fields that have been created by the JSONata mapping. And that concludes the demonstration. So here we have actually quite a quick demonstration showing the concept of how we can very easily migrate information between App Connect Enterprise version 12 and App Connect Enterprise version 13. And on the screen in front of us, we can see we have a couple of Command Console windows already open. In the top one, we can look at the version of the product that's involved here. It actually happens to be 12.0.12.0. And if we run an MQSI list command on this particular installation, we can see we've actually got quite a large number of integration nodes. This one in particular has been exposed on an HTTP administration port 4453. And if we do a listing of my node, we can see what it contains. And my node in this example actually has three different integration servers. Server 2 and Server 3 don't actually have anything deployed to them right now. But inside my Server 1, we have an example of a single application containing a message flow. So having executed the stop command against that integration node, we're then going to use the MQSI backup broker command that's been with the product for a very long time, whose purpose is to generate a zip file that can be saved to disk on the local file system. We're nominating a directory there, and if we look at the base of the screen, we can see that the zip file has been written to my local temp directory in a subdirectory called migration demo. And what we're going to do next is actually switch to the other window that's on screen right now. In fact, if we make that a little bit larger, we can stretch it up to the top of the screen. And then in this console window, we'll be interacting with version 13. It's installed on the same physical server here. And again, we can run the MQSI service command just to prove the version of the product that we're interacting with in this second window. And the purpose of what we're going to run next is to take the definitions inside that zip file and then use another command that we call the IBM int extract node command. This precise form of the command is actually new in version 13. Previously, it was been called the MQSI extract components command. And the parameters that we pass into the IBM int extract node command include the backup file on disk. So we're just typing in the name of that zip file that we generated a moment ago. And then there are another couple of parameters. One is dictating the name of the input integration node that we're migrating from, which in this example is called my node, and also the name of the output integration node that we'd like to generate. You can rename a node as part of this process, so we're choosing to call it my node migrated. And you can see from the feedback on the command line there that it has successfully loaded the configuration from that zip file. And in the case of server 2 and 3, it's not needing a JVM. It's giving us that piece of feedback there. And then a very straightforward command to actually start up the integration node, and we'll be up and running with the newly migrated node. Now, as part of version 13's installation, by default, we generate some certificates which are actually self-signed, which can be used to secure the administration port of version 13. So when we go back to our web browser and we change in the address bar to go back to the same localhost, same port 4453 that we started on, we'll notice that to begin with, we were unsuccessful in getting administrative control until we changed that URL task there to note the fact that we want to use secure HTTPS in order to talk to the integration node. And then we're up and running, and we can navigate down into the server, and we can see that the JSON application has been migrated successfully, including the flow inside there too. And that concludes a simple demonstration of the process of migration.